Jacob walk in? So now, where we left off, well, let's talk about the homework before I go to where we left off. There were two parts to this homework. The first part said, this is a profit table. Do mini max regret approach and make a recommendation. You should have said, okay, profit table, mini max. You looked at your notes, you said, step one, find the best possible outcome for each state of nature. That's the biggest mistake, usually, if this is on a quiz. I'll have people use the find the best one in the decision and do the process, but you gotta have somewhere in your notes. You're finding the best one for each state of nature. So since this is profit, 770 would be the best profit in state of nature A. So we subtract everything from 770. 770 from 770 is 0. 770 from minus 510 is 260. 770 minus 650. We do the same with the second state of nature, 650. The third one, 780, subtract. We now have our regret table. The next step, find the maximum regret for each decision. Now we're leaving the state of nature. Now we're looking at the decisions again. Decision 1, the maximum regret would be 120, the largest number. The maximum regret in number 2, or decision 2, is 260. And the third one is 110. The last step is for you to make a recommendation based on whichever one of these maximum regrets is the lowest, the least amount, which is the 110, so you should be recommending the third decision, which is a large number. That's that problem. Here's the confusion I think I've already seen from a couple of students on the second question is missing this word right here. It says, look at the same table, but now it's a cost table, not a profit. So when you're doing maxi max, hopefully you wrote down it says maxi max, the best of the best. Look at each decision, find the best. But you've got to say to yourself, okay, wait a minute, this is cost. So if you look at decision 1, I think a couple people said 780 is the best. If this were profit, it would be, but this is cost. And as a manager, you want your cost to be as low as possible, so you can have profit. So 610 is the best one in decision 1 as a cost. 510 is the best one in decision 2 because it's a cost. And 550. So I've got, where's my word? What? There we go. 780, wait, where am I? 610, 510, 550 are the best because it's cost for each decision. Then you pick the best of the best. Well, since this is a cost, I'm going to pick the lowest number. Recommend medium, building, lowest of least it could cost. I don't know where that is. Just this answer posted already? It could cost of that. Now, maxi min. Maxi min says find the worst for each decision. Pick the best of the worst. That's how you always remember it, the best of the worst. So I go back up to the thing, and it says this is cost now instead of profit. We're looking at the worst would be the highest cost. Small building, the 780 would be the highest. Medium, the 710. Large, the 770. And now, since this is cost, you're looking for the best of these worst, which would be the lowest. You're recommending medium again. Medium's the winner, whether we use maxi max or maxi min. Those are such naive techniques, though. I hope you in real life end up really never using them. And I hope that you have additional means to say, let's get the probabilities of nature 1, 2, and 3, and now use expected value. Expected value is on your in-class assignment, not your homework. The only thing we didn't cover on the homework and in-class assignment from this chapter is expected value of perfect information, which is because we didn't get to it, but we're going to do it right now. Any questions on that homework? Do you see something that you forgot to do? That's fine, you can hand that in late. But if you saw something you got wrong, sorry, there's no redos. Don't be wrong, I gave a redo, I may have given 2, because they handed it in right after class was over. So far in advance, I had a chance to look at it, and I'd say, look, reevaluate question 1, reevaluate question 2, and I kind of will give a redo. But, the day is due, I don't have time to give a redo, there's no redo. But if you see part of this you forgot to do, you still can have that. There's a question. That's a question. You're good?
Yeah.
Okay. All right, so now, chapter 13. Chapter 13, we left off with the expected value, and I believe we were given the probabilities of it, 80% and 20%. See this right here? 80%, 20%. And we went straight across for each decision, and we said, which one did we recommend, small, medium, or large, based on, it was a profit table from this PowerPoint, and our expected values were 7.8 million, 12.2 million, 14.2 million. What did we recommend? A, B, or C? 1, 2, or 3? Small, medium, or large? What are you recommending based on expected value? The largest number or the smallest number? And again, because it's profit. So you're saying I'm recommending this. This was our in-class assignment. You got it almost just like it. So you got it. This is the chance for you to answer some questions I'm asking. I'm done. Even though we could possibly lose $9 million using expected value, because the opportunity cost, or really the gain, if this works out, is so large that it's recommending going after that one, the biggest one, right there. Okay. Now, we have a chance for additional information. This company approached us. They said they could do an analysis or a survey of some kind to give us a better idea of really what the possible outcome is for each state of nature, which would give us a hint as to which one would really be a better decision. How much are they at? They said, all you got to do is pay us $100,000. Here's how you say to yourself, this approach will say to you, should you spend the money? Is it worth it to spend that money for this additional information that would help us possibly get more profit? And here's how you determine it. You ready? ZVPI, expected value of, and I want to make sure you realize, if you get to the textbook and you're trying to review for this quiz, you're going to see expected value with perfect information, expected value without perfect information, and then there's expected value of perfect information. That's what I'm teaching you. That's what's going to be on your quiz possibly, or your final part. Expected value of. This right here, the one you're recommending, this is expected value without perfect information. Just the regular expected value. And in order to figure out how it was the most you should spend for additional information, which is called the expected value of perfect information, you got to use this. We're about to find the expected value of the best possible scenario, and then we subtract this expected value, and the difference is the most we would want to ever spend to get to that perfect situation. All right? And we don't even want to spend all of it because we're just going to go break even. We want to spend less than this calculation. Right now, we're going with large because it's estimated. You know, we're expected to possibly, if we have some bad going on, some good going on, we should bring around 14.2 million profit. All right. So I want to go back to. This is my first time using the pen. You ready for it? First time using it in the lecture. Here goes our table. Or is it the table? Yeah, this is it. You ready? Okay. When you're finding the expected value with perfect information, you're saying, if I've got additional information in state of nature 1, and the information is telling me state of nature 1 is going to take place, strong demand, what's the best outcome I could get with this information then? How many million? 8, 14, or 20? The 20. That's what you're looking at, the state of nature. What's the best possible result if I did get more information, pay for it? What's the best result if it's the information told me this is going to be your future? 20. So I'm going to go, what was the probability of strong? Was it 80%? So I take, is this working? First time. It's not even working. Hang on. First time. Okay. Go with this. 80% times, what was it, 20? Okay, plus. The other one was 20%. I haven't got it mastered yet. What's the best possible outcome if the additional information told us that we're going to end up seeing a weak demand in our future? What's the best possible outcome? 7 million. No, 7 million. This is going to give us a large number. This is going to tell us, here is your expected value with information, with additional information. And it's going to be bigger than the expected value we calculated already without additional information. And it's the difference is the most we want to pay. Let me review. You're being approached and you're being told you could get some additional information, but it's going to cost you this much money. And you want to calculate if it's worth the money. So you want to say, what's the best, we found out that state of nature 1 is our future. What's the best result? 20 million. If we found out the state of nature 2 is our future, what's the best result? 7 million. You take those now and multiply them by the appropriate probabilities that were already given to you when you did the expected value, 80% and 20%. So 80% times the 20, 20% times the 7, what did he give you? Anybody? I know someone did it. Tell me. 17.4 million. Go back to expected value now. Let's go back. We calculated this, the previous question, and it said we should expect how much without the additional information. What's our best result here? 14.2. Yeah. And the difference, I see a 0.27, $3.2 million. They asked for 100,000. We have the possibility of making an additional 3.2 million with this information. The 100,000 do it. Let's do it, right? Makes the decision easy. So that's how you come up with the most you would ever spend, and possibly getting more information that could lead you to what better result is and what the future has in store, what the uncontrollable nature is. Not always the economics, that's unpredictable. Something's out. Sometimes it could be like you may need to have the city council approve a permit you're asking for to change a property from residential to commercial for this project to happen. The vote's out of your hands, but you've got to keep going with this decision because you've got things you've got to pay for. And so somebody says, well, I could find out exactly how the vote's going to go if you pay $30,000. It's kind of a weird one, but that's an example where you could actually find out then what the future has in store, so you just have to calculate if you're going to come out ahead by paying that money or not, if it's worth it. 20%. The story, the original story said there's an 80% chance of state of nature 1 and 20%. You got to use those same probabilities. Your in-class assignment, though, used different probabilities, which were 68%, 32. Anybody? Is that what it was? 68. So in that case, you would have used 68%, 32%. Whatever probabilities you use to get your expected value, same probabilities you would use to get this information. Okay? That's the last step of chapter 13 we're covering. So this chapter is done. Ready? That was one of your easiest chapters. All right, that's it. We're going to chapter 10. There it is. Oh, let me save that. I'll post it on Blackboard. Look at it. I took notes. I'm saving the notes. I'm going to post it on Blackboard so you didn't have to take notes. That's my goal. By the way, these PowerPoints, you're the first class to ever see them. You're brand new. I'm teaching this class. I've taught 25 different classes, but this class I've been teaching probably 12 years. So I changed the PowerPoints after about 7 or 8 years. So this is a brand new PowerPoint. I don't know what that means because I get lost in the art. Right. We're going to study 4 of these. Prepare you for operations management. And we're not going to get in depth on each of the 4 because you're going to hear about them again in operation. But I'm introducing you to these 4 most commonly used ones, which is EOQ, called economic order quantity, which is the basis of all the other ones anyway. That's a big deal. Economic production lot size is used in manufacturing. Planned shortages, where you purposely run out of inventory. It's a rare situation, but it's where you know someone will come back for it. It's such a unique item. And then this is really common, quantity discounts. When I was managing a department and we had to buy things, I would get hit with suppliers all the time trying to say, hey, if you just buy 1,000 more, we'll give you 10% off the whole thing. And a rookie manager will go, 10% off? Count me in. Not taking everything into consideration. There's a holding cost in those additional 1,000 that have to be taken into consideration. So this is very common. And one of the most common that managers will make mistakes on and cost the company money because they don't take everything into consideration. So these are the 4 inventory models. The whole purpose of these inventory models is to make sure that you're ordering the right quantities, you're making the right quantities, you're warehousing the right quantities to keep your costs as low as possible. What happens, I almost didn't use the pen. Again, what happens is, that's how this is done. Here we go. You end up getting, come on. Man, I just got to figure it out. There we go. Curve kind of goes like this. These are your costs. And up here is because maybe your holding cost is too high. Most inventory has what's called ordering cost and holding cost. Holding cost is your warehouse, the electricity for that warehouse, the money that's tied up in inventory, the interest you would pay on that money, whether it be an opportunity cost or a loan for that inventory. All this holding cost. When this is too high, it's your ordering cost is too high. Putting it in order together has a cost. There's a person involved, another person involved, and that could be too high. It's when you get these two costs in balance, you're right there, you got your costs as low as they can go. And that's the kind of the moment where you are doing the company a huge favor because you just stop them from wasting money in either their ordering cost or the holding cost. So that's what this is all about, is finding that point that would be the optimal amount to order or the optimal amount of payments. You ready? We'll get into it. Here we go. Boom, boom. You read this at home. Boom, boom, boom. You read all this at home. I'm coming back. I just want to get to the formula. I want to jump to, where is it? Come on. Right? Here. This formula. What slide am I on here? Can't even see it. 21 maybe or 11. One or the other. No one's following along? No one can tell me? That formula is your key formula. This is it. Right here. Square root of 2. It's always a 2. That's a constant. There's no reason to ask why. It's always a 2. D stands for annual demand. Not, the store may say, hey, you sell, I don't know, 50 pairs of shoes a week. You do not put a 50 there that you're selling. You got to say, how many weeks am I open? I'm open all year long, 52 weeks. How many pairs did I say? 50? 50 pairs times 52 is your D. Annual demand. A lot of times it's not given to you manually. You need to find what it is annually. C, ordering cost. How much does it cost to place an order? Doesn't matter how many you're ordering because the costs are involved. No matter if you're ordering 10 or 1,000, you have pretty much the same ordering cost. Everything that's involved to put an order together, including sometimes, depending on your supplier, you may have to pay for the transportation to get the order to you. That's an ordering cost. You have to pay for somebody to check that order in when it arrives at the dock, the warehouse people, and to get it into the holding areas. That's an ordering cost. That's what C sub O is. Cost for ordering. Divided by holding cost. This is the weird one. Now, I had to find these numbers when I was working for the consulting firm. And a holding cost, that's not that easy. I'd always start out in the warehouse, and I'd pick a product just to kind of at random, so I could see what the process is at the company. And I'd say, hey, do you see these toilets that you sell? And they're right here. When your truck arrives with new toilets, do they all go right here? Yes. How large, how much space does it usually use? Oh, it's this whole area right here. This meant square footage. That's important. You want to know the square footage of that area. And then you need to know the square footage of the whole warehouse. And what percent are the toilets using of that warehouse. Because you got to now go into accounting. You got to find the electric bill. And you say, what do they spend on electricity for this warehouse per year? Multiply times the percent. And that's the percent for the toilets because of that electric bill. Okay, well, what else is involved? You know, there's money involved in inventory. Well, what if they have a loan, or if they don't have a loan, they're using their own cash, that's opportunity cost. What if they have a loan, what percent are they paying on a loan? And what percent of that loan is for these toilets, right? And that percent of that interest is part of the holding cost. For this class, you'll always be given the ordering cost and the holding cost. You don't have to go through all that. But I just want you to see what's involved in real life when you're at a company. To get that number. And you reevaluate it too, because costs change.
I missed what you said the
The I. The I?
I.
Oh, divided by.
Like it's italicized.
Oh, no,
Sorry.
it's divided by.
Thanks.
Which, by the way, I want to make sure, where's my little pen here? Order of operations from math, I know all of you go, oh, this is orders of operation. Just a quick review. It's, what do you do? Parentheses and exponents first, maybe, I guess? And then it, huh? No, not yet. After parentheses and exponent is multiplication and division, left to the right. Driving backwards? Huh?
Parentheses, exponent, multiplication, addition, subtraction.
Yeah, then addition, subtraction, left to right. Am I getting the order wrong? You guys are not right. Do I have it right? Okay. You look at a problem, you say, is there any parentheses or exponents, and you attach those first. Is there multiplication and division involved? Yeah. Go from left to right. Left to right. You will get the math wrong. Is there addition and subtraction involved? Yeah. After all this, then add or subtract, again, left to right. I always see those things on the internet where it says, nobody can solve this math problem. The only reason people can't solve this is they're not following order of operations, and everybody's getting different answers because they're doing something before they're doing something else. Same with these formulas. You're about to see a whole bunch of these. Make sure you follow, order of operation, especially when we get to production lot size. You have to divide that annual demand by the annual production. If that machine were left on for a whole year, every single day, how many could it produce? That's production capacity. You got to divide. And then you subtract it from one. No matter how much I'm saying this right now, every semester I get a couple of students who will first subtract the demand from one, then divide by the production capacity. You got to divide first, then subtract. You get a completely different answer if you subtract it. Not even close to the regular. So that's why order of operations is crucial in these. So now, we're going to read a problem, and we're going to plug the numbers. This is all about you reading a problem and coming up with the numbers you plug in there. And what you're finding, when you calculate this, is you're finding for one item, these commodes, whatever, you're finding the exact amount that should be ordered from the supplier every time an order is placed. If you order more than that, you're wasting money. If you order less than that, you're wasting money. That's what this calculation does for you. It allows you to put the order together. Whenever I go to a company, I say, okay, how many did you order last time of these? And they'll say, 58. And I say, well, why? I'm just curious. That sounds like a great order, but why did you order it? And it's always because that's how I was trained. So, number one thing for every question I ask as to why they do this or that, that's how I was trained. And they've never even heard of this. Because the companies I went to were only doing maybe 20 million sales or 40 million sales. They're not doing, 100 million or 500 million sales. They're not big companies who are spending money having people that do this all day. They're medium, small companies. They don't even, a lot of times it'd be a brother and sister whose father passed away and he had this business, and so we took it over. I was an English lit major. I've never even heard of this, But they can't figure out why this company's losing money. Because they're wasting it by not doing calculations like this. And that's where they need you. This is where the jobs are. I just saw an article, by the way, it just came out. I don't remember what it was, which newspaper or which one it is on the internet, but it said the number one job satisfaction was data analyst, I think, or data cruncher of some kind, which is somebody at a company doing things like this. It paid $108,000 a year. And the people were the most happy of any job. Data decision analysis, or something like that. It made you read through the whole article to find out what was number one. It was that. So we're going to go to a story. You're going to pick out what goes into those letters, those variables for this formula. One more formula is total cost. Right here. You ready? Same variable. Total cost equals 1/2 is always 1/2, which means half the inventory, average inventory size. We'll get into it another time. Q is the optimal quantity, but Q could also be their current quantity they ordered. This is a big thing. I always, and I'll probably ask this on a quiz or a final, I will ask you to calculate total cost with the optimal quantity and calculate total cost again with the way they currently do things. Because that calculation, when you subtract the two, is how much money they'd save if they started doing things with using formulas to make the determination instead of just winging it. 1/2 times the quantity times the holding cost. There's one side. You add it to the other side, which is the annual demand, which we use in the other formula, D, right? How many we go through a year, divided by the quantity every time we order, times that ordering cost. So this determines how many orders a year you would make times the ordering cost. Demand divided by. Again, this Q, I'd always do Q with how many they order, and then I change Q to how many they should be ordering, so that the client can see exactly how much they save per year by changing that one item's ordering policy. And then the light bulb turns on. And 90% of the time they look at me and go, well, I have 10,000 different items in that warehouse. That's right. You could save that much money on 10,000 items. And they multiply times 10,000, they go, well, that's all the money, that's the profit I'm looking for. Boom. Questions answered. Just like that. That's all it takes, is changing just the way you order. One item, another item, now another item. That's how it is. And new businesses start up, and they don't have anybody there doing this. They start getting big, and they never learn this, and they're just winging it and winging it. They need to hear somebody come in and go, hey, I think I can save you some money. You know, because it doesn't seem like you're using math to figure out what to order or how many to make. All right, here's the story. Where am I? Where's the story? R&B Beverage is the largest, there's a back one. Where is it? Here we go. Where is it? Again, this is the first time I'm using it. Here it is. R&B Beverage is a distributor of beer, wine, and soft drink products from the main warehouse in Columbus, Ohio. R&B supplies, see, I'm going to change that now that I realize I forgot it. Yeah, they're in Ann Arbor. They're in Flint. Let's change that to Flint, Michigan. And there are nearly 1,000 retail stores that they supply to, okay, beverages. The beer inventory, which constitutes 40% of the company's total inventory, approximately 50,000 cases is their average inventory. We don't, the parts of this formula we're learning, we don't need that actually. With an average cost per case, now this we need. The average cost per case is $8. The reason we need this is because holding cost is usually calculated as a percent of the cost of one item that gets put in the warehouse in that spot. Anything that goes in this spot, let's say it comes up with 10%, ends up being 10% of our costs of that product in a year's time. So if I asked you, what's the holding cost for one case of beer, it'd be 10% of that $8. And that's the number you would use for the holding cost of the formula. You with me? All right. The warehouse manager decided to conduct a detailed study of the inventory costs associated with Bud Beer, the #1 selling beer from the company that distributes it. The purpose of the study is to establish how much to order and when to order decision from Bud Beer that will result in the lowest possible total cost. Exactly what we're going to do. Use it. But I want to make sure you notice, where's chapter 13 subject list? I'm at chapter 10 subject list. That's what I want you to notice right here it says, for economic order quantity, which is where we're at right now, these are the areas that we're going to go through, and these are the only ones you need for this part of this chapter, even though there's some additional ones. The optimal order size, total annual cost, this is the one we haven't talked about yet, reorder point, and number of orders per year that they're going to make, how many of them. Now, they went ahead and looked back at the past 10 weeks for just the, is it Bud beer? What's the beer called again? Is it Bud beer? Huh? Bum. Bum, B-U-M? B-U-B. Oh, Bum. Okay, so they went back and said how many Bubba beers cases have we sold each week for the last 10 weeks. And if you notice, they're kind of close to each other. They're not exact, but they're close enough to be able to use this formula. And that's the thing about this formula. When you get into operations management and you have where you have where the amount you sell each period varies a lot, you got to change the formula a little bit. You learn that in operations. I'm just introducing you to it. So in this case, we have some consistency here. So we can go ahead and say we have Bub, with a B. Bub beer sales are approximately 2,000 cases per week. Got it? That's demand. The story will say this is a test problem, and this Bub beer distributor sells 2,000 cases per week on average. So the formula, you got to switch that to demand. Somewhere in there is going to say how many weeks they're open. And if it doesn't say, you must assume they're open every week. How many weeks in a year? 52. 2,000 times 52 is how many cases a year? Huh? What? Where? Come on.
104,000.
Thank you. 104,000 cases a year is the D in both your total cost formula and your EOQ optimal quantity formula. You just got it. That's what you got to do with these stories. How many are they telling us to go through in a certain period of time and make it into a year demand, okay? Man, it's sweating. So hot here. I had to say that for the camera. It's so hot here that the camera has no idea it's that hot here. Matter of fact, it's 82. And you got slow. I think it's because of the fan. It feels like 85. All right, so now, how much should we order? What's our total cost? Blah, blah, blah. Holding cost. By the way, this is a good read when you're at home because it goes more into detail how to come up with that holding cost. Like I told you, you're asking this person how do you put an order together. Order cost and the holding cost too it gives you. The holding cost, you want to look at how much money's involved in the warehouse. If it were a loan and they had to pay interest on it, how much would the interest be? That's all part of the holding cost. I want to tell you, I did a company that had a big warehouse that was refrigerated. You talk about a holding cost. You got to take into consideration that they have to keep everything in that freezer. It was a freezer, giant freezer. The amount of electricity they have to use to keep everything frozen in that freezer 24/7 for a whole year is a large holding cost. So that was a big deal. But we say the number, they estimate, this is again, they're adding all holding costs, what's involved, but it all comes down to, after we do all the calculations, if this is the problem on your quiz or homework, it will say, and the annual holding cost is 25% of the cost of one item for a year. So when you are now going to use the formula for C sub H, your holding cost, you got to figure out what 25% of the cost of one case is. Were we told the cost of one case? $8? 25% of the $8, there's your holding cost. It costs $2 a year for each case to be in the warehouse right there in that spot for a year's time. 25% is what we calculated our total cost for this warehouse to be for that spot. So $2. You'll be given the cost of an item or whatever it is in the story, and you'll be given that percent. Once in a while, you'll be given this number, not the percent. You'll still be given the cost maybe of the item, but it will say, and the holding cost is $2 a year. Just be given it. You haven't calculated that. Just use the $2. Don't get confused because you weren't given a percent. So now, I'm jumping to, we got our annual demand, you said 104,000, correct? Our holding cost was $2, is that right? All we need is our ordering cost. Where's our ordering cost? There we go, blah, blah, blah. This cost, considered regardless of the quantity. You got your putting together the voucher, processing the order, payment and postage, telephone, transportation. The biggest cost is the employees involved. That's always been the case when I put together ordering costs. There's a warehouse person involved, there's a person in accounting involved, I'd have to go to payroll, see what they get paid, I'd have to say what's the average amount of time you put in to put the order together, what's the average amount of time you put in, multiply it, you gotta figure out what the pay is just for that time, including benefits. I have to figure out the cost of benefits. You'll always be given that ordering cost per order for this class. But in real life, I'm just letting you know what's involved. Here we go, blah, 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 blah. The company says, every time we put an order together, it costs $32 regardless of the quantity in which we're ordering. You now have your ordering cost, $32. Your holding cost, $2. Your annual demand, $104,000. You got our D, C sub O, C sub H. Is that it? Is that all we need? Let's go to the formula, back to the formula. Where is it? Right here. Square root of 2 times, what's D? 104,000. C sub O, what number goes here? 32. Divided by, what number goes there? $2 holding cost. Calculate it out. I did it for you. By the way, I just realized today that it was not on the PowerPoint, so I hand did this and I posted it. So if you downloaded the PowerPoint, where is it? I'm sorry. Really confused. Where's our answer? Yeah, there it is. Thank you. Plug it all into the formula. The company should be ordering 1,824 cases every time they place an order. You ready? Old habits are hard to break. We are going through 104,000 cases a year, right? We were told we did 52 weeks, and how many a week? I can't remember. 2,000, so that's how we got the 104. This is our annual demand. We're ordering 1,824. You can't order a quarter of a case. So we round it to the correct number. If we take how many we go through the year, how many we order every time we place an order, you've just found the number of orders placed a year. Give me the number. I thought you were saying 47 or 57? 57. There are 57 orders per year placed if the optimal quantity is ordered. So now, we know the optimal quantity, we know how many orders per year. All we have left now is our total cost and our reorder point. Now, I want you to write a note about reorder point. If anybody has not signed in, has everybody signed in? You guys? You never get, how did you get to them and not you? Same here, you didn't get it too? I got it. I'm not saying it. It should be just purely a coincidence. All right, let's do total cost. Wait, I forgot. I want you to write a note about reorder point before I forget. You ready? The key to reorder point is how many will be going through, how many items or cases in this case will be going through during the time that it takes for an order to arrive once it's placed, called lead time. L-E-A-D time. Lead time. You ready? Lead time, this is what you really need to know. Lead time is the amount of time it takes from when you place an order that the order arrives. That's lead time. Long time ago, many years ago, like the auto industry. Does anybody have any relatives who work in the auto industry? Ask them about what's called just-in-time inventory. They still do it, right?
They try.
Well, it was a big deal like the 1980s and 1990s. Everybody we're going to just-in-time inventory. They realized that having an inventory that's too large is holding up so much money that could be used to expand or do other things, that there's a huge opportunity cost in having too big of an inventory. So they said, we want to be able to place an order right at the moment that we get to a certain point in inventory, so that as production keeps going, and we're going through that inventory, that the truck with the new orders arriving as we just have a few left, so that it gets restocked and everything goes smooth. And we have the least amount of money then held up in that inventory. Right? You're right. There's problems in it. And once you, in real life, when you find that reorder point, you will end up making adjustments to it to say, yeah, I think I need to order a little sooner. So I have that cushion. But that's money wrapped up. And if you're a person who owns the company, that's a tough decision. That is a tough decision. That means money out of your pocket. So now, you ready? The reorder point is the amount that you would go through during the lead time. And the lead time is the amount of time it takes to get the order there from when you place it. I believe when we get to this story, I better confirm it before I say this, but I believe it's going to tell us that Bud Bubba Beer is really customer oriented. And they make a promise that they will get our order here within. Is that an emergency? Oh, that's your computer?
Yeah.
I thought it was coming over the speaker. Boy, I lost my train of thought on that. You ready? Bud Beer is so customer oriented that they're telling us that from the moment we place an order, they guarantee that the order will be at our dock within 2 days. 2 days. Now here you go. When you get a question on the quiz that says reorder point, you ask yourself, how many of whatever the item is will this company go through during the lead time? That's the reorder point. Let me say that again. Everybody hear it? Ready? The reorder point is however many of the item will be going through during the lead time. So if you're told the lead time is 2 days, you got to say how many cases of Bub beer do we distribute, because we're the distributor, in the 2 days it takes to get the beer. So what do you know about how many you distribute? What do you know? How many? Because there's 104,000 a year. There we go. We can figure out how many per day. We can figure out how many in 2 days. We just found the order point. But I want to go better than that. I think the story told us we go through 2,000 a week. And in the story might say they're only open 5 days a week. We can now even take 2,000 divided by 5. There's the daily amount we go through. It takes 2 days to get it here, multiply times 2. There's our reorder point. Everybody get it? So, tell me, 2,000 divided by 5 days, or 104,000 divided by 2, however many, we take 5 times 50 down. Take 5 times off. First thing to the story. That's how you calculate it. So now, it's such a new one, I don't even know which, where to jump to find that lead time here. Let's take a look. Inventory position, the reorder point, inventory position in which to put a new order in place. Says they go through 104,000 cases, like you said, per year. They're open 250 days a year. Now, why 250 days? That's 5 days a week times 50 weeks. They're open 52 weeks. So if we stick with 104,000, what there is there's 10 days of holidays mixed in there that they're not open, but they're still open 52 weeks a year. They just take days off here and there. Like, 4th of July, Labor Day, Thanksgiving. Don't get me wrong. I wouldn't give anybody a day off. I don't even know what a holiday is. I'm a non-emotional person. Every day's the same. And we're working. You better be there. All right. 104,000 divided by 250 days a year, right? We're going through 416 cases a day. The company says we can get our lead time, but Bubba Beer guarantees 2-day delivery. Guarantees it. 2-day delivery, 2 days times 416. You just found the reorder point. Every time our supply of Bubba Beer gets down to 832, and now that we have our whole inventory on computer, every time someone goes out with 100 cases or however many the truck is left with, it gets taken off our inventory. We set the reorder point in the system so it makes us aware the moment this gets to 832. That day, we got to place an order. Because if the 2 days it takes, waiting for that order to arrive, we're going through 832 most likely out the door, and that order's arriving right as the last case is heading out, and we restock, and that way we have the least amount of money held up in inventory as possible. That's called just-in-time inventory. That's the only way to have the least amount of money there and still provide customer service. Unless you purposely run out, because the item's so unique that you know the customer's going to come back, Because the only other way to get it is 100 miles away, and they're not gonna do that. And that is another management technique in inventory. They purposely went out, just so that they don't have so much money wrapped up in inventory, and they know they're still gonna sell the item, and it has an unbelievable increase in profit on the bottom line. And that's another one we're gonna learn next week, is called planned shortages. The last thing, all the other stuff on this PowerPoint you don't need to learn except for one more thing, which is total cost. Let's go to total cost. I passed it up here. Right here. You ready? 1/2 times the quantity. The applicable quantity was, we don't even have it here, 1,324, I think. Does that sound right? 1,824? 1,824 is going to be our Q. Holding cost was $2. Does that sound right? Help me. Yes. Demand, annual demand was 104,000. Quantity, again, 1,824. Ordering cost, 132. That's it. You got the formulas. It's just a matter of reading the story, plugging in the numbers. We broke it down here, 104,000, $2, 32. So what's this? 1/2 times 2. So they this ends up being just Q, because the 1/2 times 2 is just a 1. There's Q. 104,000 times 32 is 3,320,000. All you got to plug in now here is 1,832. Is that the number? And 1,832 right there, and that's your total cost. By the way, I bet you that this divided by this is going to be 1,832. Because usually, the holding cost and the ordering cost, here's your holding cost, here's your ordering cost, they have to be in balance. So if this one is just Q, 1,832, then this is probably 1,832. Did anybody take this divided by 1,832? What'd you get? 1,832 or 33 because we rounded or something like that? Yeah, that's what this whole thing's about, is getting these two costs in balance, because that's the only way to keep your inventory costs as low as possible. And I can't tell you, most companies, almost probably 80% of the companies that are doing less than $20 million a year in sales are not doing this. And there's thousands and thousands of companies that are not doing this. All these years later, this formula hasn't changed since I was in college, and that's like your whole life ago. And they're still not doing it. That's it. That's EOQ. We got one more. How are we doing on time? We're okay? There's no in class today. There's no homework due on Tuesday. We're just absorbing. We will have an in class when we finish this chapter on Tuesday, and you will have homework assigned on Tuesday. It's always at the end of a chapter. It'll be due on Thursday. So you kind of see the routine, right? All right. You guys will have this class down. You'll still hate it, but you'll have it down. You'll have it all figured out. Okay, where are we at now? EOQ, optical. Is this me? Ah, here it is. Right, I did it right here. All right. And now we're going to this one. All this stuff you're going to learn in operations, and now we're here. Production lot size, inventory model, economic production lot size. Big word next to this. If the problem is talking about manufacturing an item, this is the formula. Let me say that again. This is the only one of the four that's all about you're manufacturing something, and the question is how many to make. A lot size stands for, another word for it is called a run, by the way. We used to always refer to it as a run. A lot size is how many do you make before you shut that machine down, retool it, and you're making something else for a while. And then you shut it down, retool it, and make this again for that quantity. What is that quantity, the perfect amount? Now, this, when I worked at the consulting firm, I went to a lot of manufacturing companies, and I always asked that question when they were making something. I walk right up to the person making it, because they always they have a company meeting on my first day. He's here from Consulting. Answer any questions he has. Give him everything he needs. Give you his analysis. Hey, all right. So they see me coming. Hey, I see you're making these. This company's making fishing lures or something like that. How many do you make before you turn this machine off and make something else? And the answer would always be like 1,000 or 10,000. Just a really round number. No like 1,326, it'd be 10,000 or 1,000, whatever it is. And I say, okay, now what made you decide to make 1,000, just so I can understand the process? And it's always, this is how I was trained. This is how the previous person did it. They made 1,000, I made 1,000. And what's happening is if you're making too few before you shut that down and make something else, then you're having to set it up too often, and you have this outrageous setup cost. If you're making too many, and you're not shutting it down often enough, then you have this huge holding cost because you have all this extra you're making. And it's getting that setup cost. It's not an ordering cost on this one. It's called a setup cost. It replaces the ordering cost. Setup cost, and you have a holding cost. And you've got to get those in balance to have your cost be as low as possible. When you get those in balance, it means you leave that machine running, making these fishing lures for this many. And then you shut it down and reset it up for something else until you get to a point that you need to make this fishing lure again, set it up, make that many again, the exact amount. And that's how companies save money. They're wasting it. So, in this story, what do we got here? Blah, 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 blah. Blah, blah. Is there anything else other than blah, blah, blah? Alright. Let us build the production lot size model, running and holding costs. Where are, come on. Hang on. Here. We'll go right here. This is the formula, total cost formula for a production lot size, and it's, believe it or not, it's very similar to EOQ, but this little change. 1/2 again, it's like almost all of them. Instead of, I can't remember what was here in the other one, but right here, this is where you got to take that annual demand divided by, if that machine were on the whole time this company's open, how many could it make? Called the production capacity. If that machine made nothing but those fishing lures every single day this company's open for a year, how many could it make? Production capacity. You'll always be given this. Sometimes we'll say, that machine has the ability to make 1,000 a day. And then you'll say, and this company's open 300 days a year. You just found capacity. 1,000 times 300, 300,000. There's the capacity. Does that answer your question?
You said that was annual demand, so isn't that capital?
And this one is annual demand. Now don't get me wrong, you can use, as long as these two match up in time intervals. If this is weekly and that's weekly, it will work. But here, this has to be annual. So I always suggest doing annual for these two. Because you're going to have to convert to annual anyway. So you want, I say annual demand divided by annual production capacity, then subtract it from 1. So if these turn out to be 0.44, you subtract it from 1, that's 0.56. That's what this turns into. You got to subtract it from 1 after you divide it. Then you multiply times 1/2, and then you multiply times the quantity. We don't know the optimal quantity yet, but I always plug in however many that person told me they make every time they do a run. Because I want to show them how much they're spending in total cost now, the way they're doing it, so they can see how much money they'll save if they just change that one process. This one item. You just change how many you make before you shut that machine down. This is how much money you save. Again, whoever the people are that I'm presenting the presentation of my results to, the light bulb turns on and they say, well, wait a minute, we're making 4 different things with that one machine, and we've got 7 machines making things. You're saying by just changing how many lures we're making on that machine, every time we turn it on to make lures, we're going to save, it would be something like $3,000 a year. We're saving $3,000 a year? Well, and then they realize, if we change the amount we're making, I'll make 5 different things on that one, 5 different things on these 7 machines, we could be saving that much money on every one of these? Yeah, that's the whole point. Using math to make the decisions instead of just saying, oh, this is how we've always done it. And that's happening. New businesses are going bankrupt, new businesses are coming out of nowhere, and they're doing the same old thing. And they're going to go bankrupt because they're wasting money. This is annual demand, this is that quantity. Again, this is the holding cost, but this is not ordering cost. This is the change. This is setup cost. because they're not placing orders, is how much money's involved, and now you shut it down making something because you're going to set it up to make lures again. What is the cost involved in setting up lures? I go back to General Motors because you're familiar with it. And I'm from the General Motors family. My parents worked at General Motors, and I'm sure someone's like from Genesee County somehow related to General Motors. Well, General Motors had a huge setup cost because for them, they're making something like for a whole year. If you recall, it's been a long time, but I think it's like in July. A shop at General Motors, a plant was shut down for like 2 weeks. Did anybody confirm that? Was it 2 weeks? And it was called changeover, right? They were setting up all the dies and presses with all the new tooling. It takes them 2 weeks. So think about the setup cost involved in something that large. This is just one machine we're talking about right now. Yes, they have 5 or 7 more, whatever. This is one machine. But there's still a cost involved in changing that over, whatever the machine does, the process, changing the way things are being done on that manufacturing process to now make the lures again. That's the call to setup cost. I'm going to be giving it to you, but in real life, you got to say, okay, who's involved in changing this setup? You got to go look at what they're paying, how much time it takes. There's a whole bunch involved, but for this class, I'm always going to give you that setup cost. And that's what you're plugging in right here. So don't get confused and start looking for an ordering cost. This is setup cost. Here is the optimal lot size, or what I call one. How many should be made before you turn that machine off to do something else with it. Here it is. 2, well, the square root of, 2 times annual demand times setup cost over, in parentheses, 1 minus annual demand divided by annual production capacity. Now earlier there was a small d and a small p. As long as these two numbers in this part of the formula are for the same interval of time, instead of being annual, if this were weekly and that's weekly, you'll still get the right answer. If that's monthly and that's monthly, you'll still get the right answer. But if you hate numbers, just write notes to make this annual demand, annual production, because you've got to get annual demand for the top anyway. So just do that and you'll be okay. Annual demand divided by annual production capacity, subtracted from 1, multiplied by the holding cost. The holding cost is the same as the previous formula. It could be a percent. But instead of it being, let's say it was 25%, the other one was $8 a case, because that's what it costs to buy it. This formula is the holding cost is a percent of what it costs to make one of whatever the item is, a fishing lure. What does it cost to make one fishing lure? Oh, $5 or $4. And you find out the holding cost is 25%, so 25% of $4, the holding cost is $1. So the holding cost is most likely given to you as a percentage, and you multiply it times the cost to make one item. Or it can be given to you as just the holding cost, you just use it. Now, I don't know where the story is. Let's look at this one. Beauty Bar Soap is a company that's producing cases of soap. And they annually, they sell, or they have demand for 60,000 cases a year. What is this? What letter did we just discover? What variable?
That's annual production.
No. D, that's the annual demand. They're not making 60,000.
Their production line has capacity.
Sorry about that. My bad. I read it wrong. Man. Read extra credit? Sorry, I don't give a fuck. Couldn't be more deserving. Couldn't be more deserving. No such thing as class, but man, I wish I could. Capacity is 60,000. That's our P. Now we're going to divide that into annual demand. The annual demand is estimated to be 26,000 cases. So right there, 26,000 divided by 60,000, that little D over P part. That's in both your total cost and the optimal quantity to produce. The cleaning, preparation, and redoing whatever the setup cost. Every time we reset this production line, there's $135 involved. There's our setup cost, C sub O, setup cost. The manufacturing cost, to make a case of this soap, the manufacturing cost is $4.50. The annual holding is at a 24% rate, $4.50 times 24 cents. Our annual Holding cost for one case of soap is $1.08. We have our C sub H, we have our D, we got our P, we got our C sub O, the setup cost. We can plug it all in. Let's go back to the formula real quick. 2 times, what was the annual demand? 26? No, not 26? 26,000. Setup cost was 100 and what? No, a dollar what? No, 135? 135. 1 minus, what was annual demand? Again. 46,000 divided by 60,000, then subtract it from 1. Holding cost was $1.08. You do all that, the last step, square root it. There's how many we should be making every time we set this up to make cases of soap. Right? Where's our total cost formula? Let's plug in the numbers. 1/2 times 1 minus annual demand, you said was 26,000. Annual production capacity 60,000 times, oh, we don't know the optimal quantity yet. When we calculate it, we plug it in here. Holding cost was $1.08. Does that sound right? I see head shaking. Okay. Annual demand again 26,000. The optimal quantity we're about to calculate, and the setup cost was 135. You got that all done. Real quick, please plan ahead. You will most likely be asked either on that last one or this one or one of these. They currently are making, I don't know what the numbers are going to turn out to be, but I want to just say, they're currently making 1,000 every time they do a production run. You're plugging in 1,000 here to see what the total cost is. You calculated they should be making something else. You plug that optimal quantity here to see what the total cost is, because the question is going to ask you, how much could they save on just this one item by changing the amount they make before they shut down the machine? I want to know how much you can save to the company by being there and telling them how to do this. Let's look at it. 2 times 26,000 times 135 divided by 26,000 divided by 60,000, subtracted from 1, multiplied by $1.08. 3,387 cases of soap should be made before they shut this down to make something else and come back and make more later. Total cost, 1/2 times 26,000 divided by 60,000, subtracted from 1, same as we did up there. Now we have the optimal quantity. We're going to do this again with the number 1,000 there, because that's how many they're currently making, so we get total cost. $1.08 holding cost plus 26,000 divided by 3,387, or 1,000 if we want to know how they're doing it now, times the setup cost, 135. The total cost of the year, if you make 3,387 cases instead of however many you're making now, 1,000, is $2,072.73. Let's put 1,000 there and 1,000 there and see what that number is. And you're gonna say, let's say they're up, guessing there, maybe they're saving $500 on just this case of soap. One. $500 a year doesn't sound a lot, but how many different processes do you have going on here that possibly are making the wrong amount? You could be saving 500 to a couple thousand on every one of them, and then the light bulb turns on. They go, oh, this is where we're wasting our money, or that's where we're wasting money. Inventory is probably the #1 place small and medium-sized companies are wasting money and can't figure out why they're not making the appropriate profit or losing money. Why are we losing money? And this is one of the #1 reasons is inventory control out there. All right, so total cost we did, optimal quantity ordering. We're gonna go back to I think that's the only 2 you got to learn. Let's see. Optimal run size, total annual cost. There's only 2 parts of this particular inventory model you need to be prepared for. But you got to be prepared to do it for the optimal amount and the current amount they do to see how much they save. Everybody with me? How are we doing in time? We got a few minutes.